Today we are going to look at the new Kubeflow components for KitOps. You can find these components in the KitOps GitHub repository under Build, Docker Files, and Kubeflow components. We have two components. The first one is the push model kit. The push component packages and pushes your ML artifacts to model registry. And then there is the unpack component. This one is going to unpack your model kit artifacts from a registry. You can use the unpack component for retrieving training datasets, configurations, and similar things that you have already packaged as a model kit. Now, for this demo, I'm going to use an existing example from Kubeflow that has been adapted to use model kits. The demo is actually very simple. It's a classic. We are going to train a model to predict the housing prices. The training uses 10 features and synthetic data. Note that the training is actually saving files like the model file, predictions file, the script, and README to a folder. Finally, it packages the saved files to a model kit. The model kit packaging is using the push model kit component, as you would expect, and just passing the folder where these 4 files has been saved. Those of you who are familiar with model kits may wonder how the kit file is generated or if it should be included. The component can either generate the kit file or use the one that is included on the directory. In this case, we are not generating a kit file, and let the component generate one using the kit init command by itself. So now let's run through the KFP and generate our pipeline. Once we compile with KFP, you can see that it actually generates a YAML file for us, which is our pipeline definition. So once we have the pipeline definition, I'm going to just switch to the to my browser so that we can upload the pipeline. Let's go to the pipeline view, and if you're not familiar, this is the Kubeflow's UI, which I have port forwarded to my local host. So let me just choose the file we just generated and click create. As you can see, our pipeline is created. It trains the house predictions, puts them into a folder named model kit, and the push model kit component takes over and creates a URI and the digest URI for our model kit. And now we can start running this pipeline by selecting the create run. On this view, you can see all the parameters that you can set. What I'll do here is I'm going to change the repository so that it points to a repository that I have write access, and also change the tag from latest to maybe demo, since this is a demo, and run it. You can follow the progress of the pipeline in this view, which should update in a moment. As you can see, at this point, the training has been completed. The push model kit has started. And in a moment, we should see the URIs for the model kit. Now let's go to JozuML and see the details of the model kit on the repository. As you can see, Jozu Hub already lists the latest push on the house prices on the recents. And let's switch to the demo tag. Check the contents of the model kit. As you can see, the pickle file is there, the README is listed, the prediction CSV is listed as well, and the security scan has been done. You can read the model card. And you can check to see if there had been any changes to the model kit itself. And at this point, the model kits, the two model kits, latest and the demo, are identical to bits. Next, we are going to run an inference endpoint using KServe. Let's switch back to our Visual Studio Code, and again, in this examples folder, you will see that we have an inference server definition. In the service definition, we are actually using the latest, but we could also be using demo tag as well. To enable kit URIs, we do have a cluster storage initializer. I have applied this initializer to the cluster, and you can find out all about that in the KitOps documentation. Let's take a look at it quickly so that you know where to find the information for it. This is what you need to apply in here to your cluster. So anything that starts with kit as URI scheme is treated as a model kit. Now back to our VS Code. Let's apply the service inference. And let's see if the pod is coming up. It should be moving to the running state very quickly. KServe has started serving the prediction endpoint. To be able to test this, I'm going to port forward from this service that we just created to my local port 8090. Let me just switch to another tab so that we can do this quickly. I will send a request to the prediction endpoint with 10 different features and let the endpoint do the prediction. When I send these data points, these 10 features, imagine these features as the number of rooms and square meters and similar properties. And you can see that it predicts the outcome to be 11.59 and change.